Hello everybody and welcome back to another Universe Sandbox video. Last time we took a look at how the solar system actually moves, but this time I have a interesting idea. Now, as you probably know, I am a real big fan of solar balls. I absolutely love their videos. I think they're super neat. But some of the scenarios that they show off is like, would that actually work? Could a planet actually do that? I don't mean like talk and move around, but I mean some of these situations that these planets get into, would those be survivable? That's what we're going to look at today. Now, the first video, one of the earlier videos that I want to look at, is what if the moon went away? So actually, if we go over to here to Earth, it actually doesn't have the moon. The moon is actually not currently added to the Earth. So yeah, that already kind of solves one of the questions for us. What if the moon went away? Well, it seems like it would be fine. At least in Universe Sandbox. I'm not entirely sure about real life. In the show, they mentioned that a lack of the moon could cause the Earth's axial tilt to go out of whack, throwing off seasons and that sort of thing. But obviously, I don't think it would be catastrophic. Maybe there'd be some crop shortages from the crazy seasons if the axis does actually like go completely out of whack. But that's not what I was really concerned about. Whatever. What I was interested in is, in the video, the moon actually goes over to Mars's orbit and hangs out with Phobos and Deimos, which we find out they're like psychopaths or whatever. So yeah, we can go ahead and add in Phobos and Deimos to Mars. There they are. Mars' two little small moons. If we just go ahead and throw our moon into this orbit, I don't know how far out it should be. Let's try about like over here. Because yeah, Phobos and Deimos are kind of close. Let's go like out where like Earth's moon distance would be. Probably a little bit closer. But I just want to see what's going to happen here. This might actually be stable with the moon all the way out here. I feel like orbits are getting a little bit messed up. Now they seem pretty fine. So obviously if the moon was at a normal distance, I feel like Phobos and Deimos would be okay. But, which is, you know, a little bit closer, they just wanted to say hi. What would happen then? What would happen if we were just a little bit closer? Yeah, there we go. Oh, Deimos just got braked. Deimos just got gravity braked. Phobos seems unaffected, though. Phobos is close in enough where I don't think it's going to prove to be an issue. Deimos, though, it's about to get braked again. Oh, brake check. And boom, there goes Deimos. Deimos is gone. So yeah, depending on how close the moon is, I mean, it would affect Mars's moons. But if it was at a normal distance, it would be fine, probably. But yeah, one more thing from that specific video, too. The visual they have for the moon being gone is kind of funny. It basically is the Earth with fire on one side and ice on the other, and it's like, that seems a bit excessive. I mean, this was an earlier video, and later on they established the whole axis thing. There's a whole thing where the Earth is alone for a bit, and you know, he's all wobbling around and being depressed. But yeah, if we wanted to do the fire on one side and the ice on the other, like we see at the end, that means the Earth would have to be tidally locked. So if we go to the rotational period and we set this to a year, that means this side of the Earth is going to be in constant sunlight, and this side of the Earth is going to be in constant night. And we'll see how that works out for us. Probably going to end up just like the visual shown on the show, where this side is going to be on fire, and this side is going to be frozen solid. How long does that take? Not sure. We could take a look at the surface map, and yeah, we can see we're getting pretty hot over in Southeast Asia over here, and it's getting pretty cold over in the US. We got 100 degrees C, so the oceans are going to start boiling over here. Yeah, we can start to see that. The oceans are boiling. And then negative 102 on the other side. But you could survive right on the Terminator line. It is possible. Oh, actually, take a look at that. The Earth is wobbling a little bit. Okay, does that have to do with it might just be normal precession? But obviously, you know, the biggest effect here is the fact that the oceans are boiling off, because, you know, one side is constantly aiming towards the sun. Yeah, that wouldn't be ideal. That wouldn't be ideal for life. I think life would not appreciate that too much. So, anyways, we'll go ahead and move on from that, and we'll go to the next one. Let me go ahead and check the playlist to see what the next one is.
A few minutes later.
Alright, so this next one's an interesting one. We're going to have to add something over here to the sun. So we're going to go ahead and add the asteroid belt. There it is. Maybe I'll add a couple just to make sure it's a bit more dense. There we go. There we go, that seems right. So, as you've probably heard, the asteroid belt, despite being way denser full of asteroids, is actually still pretty much a vacuum. You wouldn't really have any issues navigating through the asteroid belt with a spacecraft, but we see planets enter the asteroid belt. And one of the first planets to enter the asteroid belt is Mars, and then Mars has an encounter with Ceres, and promptly gets freaked out. So, we're just going to go ahead and take Mars, and we're going to go put Mars in the center of the asteroid belt, just to, see what happens. What happens if Mars goes into the asteroid belt? And we'll go ahead and auto-orbit, because obviously we don't need Mars to fling out of the solar system. Alright, and we'll just go ahead and take a look and see if Mars can survive being inside the asteroid belt. Let's see what happens coming through the asteroid belt. I mean, obviously we got all the other planets, there's some particles going around, but I don't think anything's really hit Mars yet. I can take a look at the surface. Doesn't seem like there's been much temperature fluctuation. I mean, obviously Mars is colder, because it's further from the sun out here, being in the middle of the asteroid belt. But yeah, it doesn't seem like it would be getting bombarded with a lot of asteroids, which is surprising. I would have thought, that because it's a planet, it would be pulling in asteroids, and it would be getting wrecked by them out here in the asteroid belt. So, yeah, spacecraft are fine, and apparently planets. They're all fine to just hang out in the asteroid belt. How much more massive can we make Mars before it starts, getting bombarded? So we're going to do 2 times. So twice as massive, about an Earth. So would an Earth-sized planet be safe? Yeah, seems like an Earth-sized planet would be relatively safe. Okay, I'm not on the same plane as the asteroid belt, actually. The asteroid belt is at a very, very big tilt, but we do go through it here. So we're going to go through it right now. Alrighty. Well, let's try twice as big again. 1.94 Jupiters. I think we're starting to affect some of the no, I don't think we're starting to affect any of the asteroid belt objects. And also it does help the fact that we are orbiting with the belt, so our relative speed to all these asteroids is low. I'm sure if we were going the other way, it probably would be a bit more dangerous, but probably not, because yeah, we're still not hitting anything. I mean, the asteroid belt could be more dense than this. I mean, in the show, it looks way more dense, but that's just artistic license. So, anyway, let's go again. 0.388 Jupiters. When are we gonna start getting bombarded? Wow, okay. 7.7 Jupiters. I mean, it's even more massive than Jupiter right now. I feel like stuff has got to be being affected by Mars's gravity at this point. Oh yeah, something got ejected. Yeah, whatever that E1 just got ejected. Sorry, E1906, E1. Boom! And now Mars is a gas giant. The gas giant of Mars. And yet it's still fine. It hasn't gotten hit by a single asteroid. So, I guess that proves the point. Yeah, a planet would be fine in the middle of the asteroid belt. Even a big one. Okay, here's an interesting one. Let's go ahead and restart the solar system here. Now, there was a whole series of videos from some early solar balls where Earth and Mars were talking about what would happen if the sun disappeared, and I feel like we all know. You take the sun, you delete it, everybody goes flying off in various directions. However, this simple conversation spirals into control where the sun, makes a bit of a smart remark about going, turning into a red giant, and it freaks the Earth out. Earth is like, I don't want this lunatic here anymore. Let's replace him. So, yeah, what would happen if we built another sun? What would happen if, let's say, over here, the Earth built Sun 2? Let's try Wolf 359. It's about 2 Jupiter radius. 94 Jupiter masses. Yeah, so we'll just say the Earth is, being a bit smart. He builds a small little star. And we'll see what happens with that. He immediately gets sucked into it. Well, good job, Earth. You did well. And let's see what this little star does. Oh yeah, this little star is definitely causing some problems. Definitely causing some problems for the solar system. Yeah, a little star and our star are having a little dance. And all the planets are just along for the ride, it seems. Up into the outer. The outer planets seem fine. They're just like, Berry center's slightly different, but we're not too affected. Oh, there goes Mars. I don't know, something happened. Mars got kicked out. Oh, there goes Venus, I think. Venus just got a gravity boost. Yeah, there it goes. It's on a highly elliptical orbit now. Mercury's actually still sticking to the sun. Mercury is, you know, loyal. Mercury is loyal to the sun, apparently. I don't think that's going to be true for long, though. Oh, yeah, here it goes. Oh, Mercury just got braked. Oh, and then it got flung. Is it in orbit of the other star now? Oh, it just got kicked into a higher orbit. Oh, yeah, well, yeah. Bigger orbit. Very elliptical, very fun. Fun little dance that they're all doing. They're all having together. Oh, that was a big boost for Venus. Bye, Venus. See you later. See you later, Venus. All the gas giants are like, what happened? And then all the inner planets are like, yeah, they're gone. But yeah, Venus, Mars, Mercury, but Earth is just dead. So, yeah, probably not a great idea. Yeah, probably not a great idea to build another star. Even if you are freaked out about the sun becoming a red giant. Yeah, not great. Oh yeah, next up in that same kind of series, they talk about Jupiter becoming a star. So Jupiter's like the most massive planet. A lot of people say like, oh, Jupiter's a failed star. Jupiter's a failed star. No, Jupiter's just a really good planet. So yeah, I mean, it's not even close to the mass of being a star. In order to get it to a star, let's see how much mass we would have to add. So to get Jupiter to being a star, we double its mass. We double it again. 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 Yep, now it's a star? No. No, it's not, even then it's not a star. Okay. Yeah, it's not even a solar mass yet. Double the mass again. No fusion yet. Okay, 0.977. It's gotta start fusing now, right? Oh no, it is a star. It's just it's a dark star? Do I have to heat it up a little bit? Do we have to start? What happens if we hit it with a laser? Can we kickstart thermonuclear fusion with a laser beam? Fusion research laser. There we go. Pew. Pew 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 pew. Yeah, I don't know. It's not becoming a star yet. Make it. Okay, I think I've gone too far. I think we went too far. What in the world? Is that a neutron star now? Did I turn Jupiter into a neutron star? I don't know what I did. Whoa, that's wild. Whoa. Yeah, but that definitely wouldn't be good for the solar system either. I don't even know what I've created at this point. I think I created a neutron star or something. Kilonova? Not even sure what you'd call it. Yeah, it's not. I thought it would be, you know, glowy. Increase the temperature. There we go. Now it glows. Yeah, there we go. Now it's glowy. Maybe it just takes a while for the temperature to get up. But yeah, I think around 90 Jupiter masses is kind of what it takes. So 90 times Jupiter's. Let's just try that again just to make sure. 90 Jupiter masses. That should turn to a star. Yeah, there we go. Star orbiting the sun, and now temperature. Does the temperature go up? Oh yeah, the core temperature is absolutely cooking, but the surface temperature hasn't gone up yet. Okay. So yeah, it's not very luminous. How long does it take for the surface temperature to go up? Probably a while. So the core, it's a star in the center of it. But we can increase the temperature until it starts glowing, I guess. There we go. How hot should it be? I don't know, it's probably too hot, right? Yeah, it's starting to cool down. There we go, there's our Jupiter star. And, the solar system is fine? Hold up. It seems like it. All these inner planets are kind of locked on. The outer planets, yeah. Good luck. But, like, I think the inner planets are probably fine. Yeah, they're just all locked onto the sun in the center. Oh, they're... It's a bit wobbly. You can tell. I mean, I feel like something like this could work. I feel like Jupiter being a star, you know, isn't the worst thing. It's definitely not on my 2025 bingo card, but, you know, it probably wouldn't end the world. Actually, saying that, let's look at Earth. Oh yeah, Earth is very warm now, I think. Yeah, it's pretty warm. Double sunrise, surprise. Yeah, so there's the sun, and there's Jupiter. So probably, yeah, I feel like, yeah, I mean, there's definitely two suns. That's definitely bright enough for you to be able to see during the day, I'm pretty sure. Yep, so if Jupiter became a star, you would definitely know about it. You would definitely know about it. Well, anyway, I think we got a couple more to go through. Let's see what else we got. Alright, we got one about terraforming Mars, and you guys know I always love terraforming Mars, so let's terraform Mars. Now, in the video, it just shows lasers. And Kurzgesagt made a video about terraforming Mars with lasers. So, I like lasers. Let's use laser. Maybe let's try most powerful pulse laser. Pew, 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 pew. That's not really doing a whole lot. Brrr. Galactic Empire Super... That might be too much. Yottawatts. Yeah, let's go down to petawatts. Ooh, that's still a lot of energy. There. Okay, that's a bit more of a reasonable laser. We'll go ahead and 10 times the radius. There we go. Alrighty. So we're just gonna go ahead and laser Mars up real quick. Just go ahead and laser it up. And what this should hopefully do is free all the rocks and stuff, free all the oxygen from the rocks, and then, yeah, the water that's trapped in the ice, that should melt, and hopefully we get an atmosphere out of this. And I'll try and spare Valles Marineris. Oh, and Olympus Mons. I see Olympus Mons over here. Okay, we'll try and spare those. But everything else can just be lasered. There we go. Alright, let's see what happens. Ooh. Okay, we lost Mars. I think we blew it up. Okay, let's try that again. We just want to warm Mars up. I just want to make it a little bit warmer than it currently is. Yeah, I guess hitting Mars with the Galactic Empire Super Laser probably just blows it up. Too much energy. Oh yeah, look at that. There you go. So the water has melted. So there you go. That is a feasible way to terraform Mars. Yeah, look at that. It's got a nice blue atmosphere. It's got some water. So yeah, lasers work. Lasers do work. Just warm Mars up a little bit. It's all it needs. It just needs a little bit of warmth. And we can go ahead and blast the polar ice caps a little bit. That'd probably be good. It's actually 70% to Earth already, and there's already a 1.71% life likelihood. One thing you would have to do, though, to Mars, that doesn't involve lasers, is you would have to ship in nitrogen. So let's just give it some nitrogen until we have, like, the nitrogen of Earth. Because, yeah, Earth has a very nitrogen-rich atmosphere. Oh, that actually reduced the life likelihood. Get more nitrogen. Oh, I guess I gave it several Earth masses of nitrogen. I guess I should have done Earth atmosphere mass. Yeah, that's a lot of Earth atmosphere masses of nitrogen. Okay, so we want to do like 0.8 Earth atmosphere masses of nitrogen. There we go. Yeah, it was a bit too much nitrogen there. How's that looking? Yeah, that's 1%. But yeah, the atmosphere is, I think, getting blown away by solar winds, so you'd have to put up shields and stuff. But yeah, no, you could definitely terraform Mars with lasers. It's definitely possible. It probably needs more CO2, actually. There we go. Life likelihood's going up. It's warming up with those extra greenhouse gases. There we go. I'd say that's pretty terraformed. 6% life likelihood, 82% Earth similarity. That's pretty good. With some fine-tuning, you could get that to work. So yeah, just heating up Mars, melting all the ice. That definitely does the trick. I don't think we hit it with the laser for long enough. I think that was probably where we went wrong. You'd want to laser it for like a couple years continuously to just completely just scour the surface, and then, you know, add the nitrogen and all the happies. So anyways, I think we got like 2 more left, and there's a lot of stuff here, but a lot of the stuff is like, we probably already know what the outcome is. Not really. The outcome's not really too shocking. Like, we got this whole thing about what if the moon approached the Earth, but I feel like that has been done to death. Like, there was a Kurzgesagt video on it. There was so many, like, moon-Earth related things that came out all around the time of, like, when Moonfall, that movie, dropped, which I actually went to go see. It was interesting. Now, if the moon was, you know, closer to Earth, Earth would rip it apart, and then it gets turned into rings. And it's a bad day for everybody involved. I don't think we need to dwell on that too much. One thing I'm interested, though. One of their more recent videos. Jupiter left because Jupiter was holding on to a secret. Jupiter was the one to eject Planet X from the solar system. And therefore, they exiled Jupiter, and then Planet X took his place for a little bit. So let's see what would happen if that actually happened in our real solar system. What would happen if we just took Jupiter and replaced it with Planet X? I'm pretty sure there is an option to just replace, right? We could add the moons. That could be fun. Yeah, add the moons. There you go. So we got all the Galilean moons and all the other ones. So yeah, there goes all the moons that Jupiter was holding on to, because Planet 9, no way Planet 9 can hold on to all that. So yeah, it's almost like what happens when you, like, delete Jupiter, for example. Oh, and what's going on in here? Is this something I did? This might be something I did. Oh yeah, is that fragments from the moon collision? Or is this like, or is this bits of stuff falling down? Oh, Earth just got ejected. What? Apparently getting rid of Jupiter really upsets the balance. More than I thought it would. Hold on, let's make sure that wasn't a fluke. Also, the asteroid belt does seem to be fine. Because yeah, one of the things that was mentioned is that the asteroid belt would go unstable. But it doesn't seem like it would probably take a while for that to happen. Although I feel like everything's probably already in stable orbits as is, with or without Jupiter. Jupiter probably helped form the asteroid belt, but I bet it would be stable without it. There are, like, the Trojans and stuff in Jupiter's L4 and L5, and yeah, those might cause problems. If Jupiter disappears, the Trojans would definitely, you know, cause problems, I think, with a lot of collisions on Earth, and all the moons as well. You saw all the moons streaming towards, like, all that would just, you know, create bombardment in the inner solar system. But just by itself, Planet 9 wouldn't really cause too many problems out here by the sun. Yeah, I think that's everything. Let me know if you guys would like to see any other, like, solar balls, things. Yeah, there's a lot of videos here. There's a lot of videos here. But yeah, I feel like most of them, it's like, either there's not really a disaster that happens. It's just kind of some silly fun. Like sure, obviously, I could go through, like, oh, what would happen if, you know, the planets were closer to each other? Like, Earth wanted to say hi to Mars or whatever. Yeah, obviously, that would not go well. You know, if Earth and Mars were being, like, buddy-buddy, like, that would not be good, you know? You wouldn't want that to happen. Yeah, because then Earth gets ejected again. And in an elliptical orbit. And goes to say hi to Planet 9. I guess we're assuming the planets have control of their own paths, right? So, like, you know, Earth can go over here if he wants, whatever. It was just some silly fun. Something I thought about that'd be pretty neat. Oh, hey, like, here's Deimos. Did that get ejected? Wait, how's Phobos and Deimos over here? Did I might have accidentally placed those, actually. But anyways, if you guys enjoyed, please be sure to leave a like, subscribe for new videos, have a great rest of your day. Again, let me know if there's any other solar balls or other content you would like to see. I'm always open to ideas. Yeah, that's one of the main reasons why it took me so long to make this video, is because ideas are just hard to come by. But, you know, I had the idea to do the solar ball stuff, and, you know, I think it was fun. I think it was cool seeing what would actually happen in these various scenarios that I handpicked. So, hopefully you agree. Anyways, see you guys around. Bye!